What are delegates? Delegates are a communication system that allows classes or objects to communicate with each other using a publish and subscribe pattern. This means the class that has the delegate, it doesn't need to know what has subscribed to its delegate, it just fires the event. An example of this could be an on-click event in a GUI element. You might want to do some work whenever the button gets clicked, but the button itself doesn't actually need to know about anything that goes on after the click event. Put more concretely in Unreal terms, this means that we have class A that has a delegate and class B that wants to know when a specific thing happens. So class A provides a way for class B to access the delegate so it can bind a function to it. And then when an event occurs, class A triggers the delegate, which in turn causes all of the subscribed functions to run. This is set up using the Delegate Macro. This macro creates types, and adding these types to your classes like ordinary variables gives you access to the delegate functionality. Delegates are also broken down into two major camps. You have the native-only delegates. These are ones that function purely in C++, and then you have the dynamic delegates. These work just like the native ones, except that they can also be exposed in blueprints. It's important to note that the dynamic delegates perform a little worse than the native-only ones, so it's better to use them only when you need to. Both of these groups can be broken down further into more specific types of delegates. The first is just a normal delegate in that it can only have one binding at a time, with every subsequent binding overwriting the previous one. And then there are multicast delegates. These allow multiple bindings, effectively creating a list of bindings that get called when the delegate is triggered. There's also a thread-safe version of the multicast delegate. And then we have the return value delegate. This is like the normal delegate in that it can only have a single binding. However, the bound function needs to return the type specified in the delegate macro. Now, these delegates are probably what you're going to use most of the time, but there are two more. One is the dynamic multicast sparse delegate. This works like your normal dynamic multicast delegate, except that it's optimized to take up less memory. The downside is that binding and removing bindings is more expensive. It's meant to be used when these are infrequent. An example of where it's used is in the actor class. These are all declared in there. Next, we have the declare event. This one is to be avoided. Apparently, the goal was to have a delegate where only the owning class call it, but this isn't enforced, and it's effectively a multicast delegate. And those are the base types of delegates. The only variations they have are the parameter variations. They allow you to pass in values with your delegate. So, for example, the onHit event on an actor class. When it fires, you get all the information from the hit, like where, how much force, and the colliding actors. There are up to 9 macros created for each type, but generally you would probably want to pack values into structs if you needed more. These apply for all of the native and dynamic delegates, as well as the sparse delegate. Once that is done, it's time to start binding. Binding to these is simple, and there are plenty of options. The main differences are between native delegates, native multicast delegates, and dynamic delegates. For native delegates, you can bind a lambda, a weak lambda, a UObject binding, where the object passed there needs to be a UObject type, so that includes things like an AActor, which is a child class of UObject. Same for UFUNCTION, the function in question needs to have the UFUNCTION macro above it. And then there are raw bindings with normal C++ object types. We can do the same with a type stored as a shared pointer, as well as use a shared pointer type, although the function itself requires a shared reference, which is easy to get. Lastly, there's the static binding, and this is just a normal static function binding. Then for multicast delegates, you have access to all of the same binding options. The only difference is that instead of the word bind, it's the word add. So instead of a bind UObject, it will be add UObject. Now, unlike native delegates, dynamic delegates can only bind to U functions. Looking at the single binding dynamic delegate, we have the bind U function that we've seen before, but there's also a macro-like function called bind dynamic. And this is the same for the return value dynamic delegate. And then for the multicast delegates, you use add dynamic and add unique dynamic macros. Triggering the events is also really simple. The function used does depend on if it's a multicast delegate or not. So for single binds, you call execute or execute if bound. And remember, it's always good to check if it's bound or not because you can get crashes. And as for multicast delegates, you call the broadcast function. Now there's this one small type that I wanted to include. It's not a delegate, but you can use it like a settable callback. It's a TFunction, and the way you set it up is you set the return type and parameters inside the little template brackets, and then you can assign using either a lambda or a static function. Then to call it, you simply call the variable like you would a normal function. And that's just setting up the delegates for the C++ side of things. To expose dynamic delegates to blueprints, we need to use the property macro. Exposed dynamic delegates fall into two groups in terms of how they are set up and how you work with them in blueprints. Starting with the dynamic multicast delegates, these are effectively your event dispatchers in the editor, and they show up with the other events like the onActor_hit event. In order to get them to show up, you need to use the blueprint assignable tag, which enables assignment and binding to the delegate, and or the blueprint callable tag, which enables calling the delegate, which ultimately calls the broadcast function in C++. Having either or just the blueprint read-write tag exposes unbinding. The dynamic single binding delegates are a bit different. You can't use a blueprint assignable or blueprint callable on them. You can only use a blueprint read-write besides the usual tags. This means you can't directly call, assign, bind, or unbind these delegates in the same way as event dispatchers. You have to use functions exposed to the blueprints to do these things. What you get with blueprint read-write though are the basic get and set nodes, which do have event connections on them. To use them with functions, all you have to do is create a function with the dynamic delegate as an input parameter and expose it to blueprints using the UFUNCTION macro, as well as the blueprint callable tag. And it will appear in the editor just like a normal function, but with a red event square input, so you can pass in an event like a normal input value like an int or a float. When the function runs in the blueprint, it calls the C++ first. Then what you can do is you can actually call the execute function on the delegate, assuming it's bound. And when this is called, the logic attached to your event in the blueprint will then run. You can also pass in multiple delegates into the function and they'll each have their own little event input. You can execute each one or even store it in a class variable so you can execute it later in a blueprint exposed function. Return delegates are set up the same on the C++ side, but on the blueprint side, it's a little bit different. You have to create a function that matches the return function signature, which means the function needs to have the same input and outputs, and pass that function using the create event node. The rest is the same in terms of how it runs for both C++ and blueprints. And that's it for the delegates, but there are two UFUNCTION event-related tags that are worth going over. The first is a blueprint implementable event. This creates an event that can only be implemented in blueprints. If you try and implement this function in C++, you will get a compiler error. To implement it in blueprints, all you have to do is right-click and add the event. It'll be under the add event category, or it'll be in the override on the left. If it has a type input, the event will also have an input kind of like the event tick event. If it has a return type, like the return type dynamic delegate, this works a little differently. You have to go to your function overrides and select it from the drop-down menu there. Calling it from C++ is like calling any other function. However, if it's set, it'll run the blueprint logic. The next tag is the blueprint native event tag. This works very much like the blueprint implementable event, except with the only difference being that you can implement it in C++. If you don't override this in the blueprints, it'll just default to the C++ version. When you do implement it in C++, the function needs to have the underscore implementation at the end. So if your event function was called, for example, on some event, your implementation function would be called on some event underscore implementation. However, when you call it in C++, make sure you only use the original function name. And with that, you should now have a good idea on how delegates work. Delegates can take a bit to really wrap your head around, especially if you're going between C++ and blueprints with all the different tags and way to set things up. But I hope this tutorial has helped make all of this clear. And if it did, be sure to let me know in the comments, like the video, and subscribe for more Unreal Engine 5 C++ tutorials. There is a link to a GitHub repository with example code, comments, and blueprint assets to complement this video in the description. And as always, thank you for watching.